How's everybody doing tonight?
Good.
I'm doing well.
Sounds like it. Birds chirping and all.
I have a screened-in back patio, and I have 4 different bird feeders in my backyard.
Wow, that's cool. Weather been
Yeah,
pretty
it
good there?
entertains the dog to no end.
Yeah. The weather been pretty good there lately?
Yeah, it was really hot last week, and then it cooled down like Thursday, and it's just been perfect.
Nice.
What's the elevation of St. George?
St. George is about 26, 2,700, just depending on where you're at. But the airport elevation is like 2,700 feet.
Hmm.
Lowest spot in Utah. What's Flagstaff? Aren't they up like 6,000 feet? 7,000?
My staff is 7,000. The airport's like 6,914.
Wow.
But town's a little bit higher. I live in Kingman and it's 3,500 here.
Okay, yeah. Good deal. You ever go out there to the Kingman Airport, out to that boneyard out there?
Oh yeah. Yeah, I work for the county and so I have the code to get in.
Yeah.
Yeah.
Well, I'll tell you what, we need to do a class field trip to Kingman because
Boneyard adventure.
that's some of the coolest stuff to see is those boneyards where have all those planes. I mean, they pretty much have everything there, don't they?
Yeah, I have a friend who works there taking apart and putting together the Embraer 145s that are sitting there.
Oh yeah. Ah, yeah, that's cool. I like that kind of stuff. It's always cool to see. Do they have any like 747s and stuff retired there?
I think so. Um, but unless like you have enough time to drive around all of it, you can't really even see all of them.
Yeah, yeah, for sure. I know that SkyWest in the past has parked a lot of their CRJ 200s there, and occasionally they'll actually go back and get one and bring it back, and if they need extra plane.
Yeah.
Apparently, they're starting to rebuild as many of those 200s as they can because they're such a hot commodity right now. Talking to
I was
Monty.
gonna say, I bet someone wants them.
Yeah, yeah. As long as the fuel prices stay where they're at, then they're they make money. I mean there was that couple years ago when the prices were so high on fuel, they started really trying to get rid of all the 50-seat aircraft and pushing the 70, 80-seat aircraft, and a little bit better for fuel, and those the 50 seaters were just losing a lot of money, so they started getting rid of a lot of the contracts and trying to park a lot of those planes, and yeah, all of a sudden now they want to start using them again because they're finding ways to make money with them. So as long as they can get some life out of them, why not? So everybody get in and take the quiz, I assume.
Yep.
How do you guys feel like you fared on the quiz?
Think I did okay. I was ready.
Good deal. How about everybody else?
Can you get 110%?
Man, possible,
I'm not begging.
Let's see here.
I feel like it was definitely the toughest quiz so far. For me, anyway.
Yeah. Yeah, the systems is always It can sometimes be a tricky one. But you know, I guess just for everybody, I think the quizzes in general are going to be, you know, easier depending on the topic, easier for some and harder for others, and then, you know, vice versa on other quizzes, just depending on, you know, your own background in aviation and your interest, I guess, too, you know. Well, let's start out here first by doing a review of the quiz that you guys just took. Is there anybody on here that has not taken it?
I haven't.
You have not. Okay.
I can log out for a bit though. Sorry, I'm behind a class. I'm trying to catch up.
Oh, really? Okay.
Yeah.
Well, let's see here. Maybe anybody else on here that hasn't taken it besides Donnie?
Sorry.
No, it's fine. So everybody else is good? Okay. Let's see here. Yeah, so Donnie, if you would like to, if you just want to log out for a little bit, just to kind of not give yourself a disadvantage on the quiz there.
Yeah. I'll just message you my phone number. You could text me when you want me to come back in.
Okay. Yeah. You have my number, right? I think I have your number anyway already. So let me just
Cool.
here real quick.
Sorry.
No, you're good. No worries at all. Yeah, just just text me your number, and then I probably already have it in here somewhere anyway, but just text it to. Okay, cool. I'll send you a text here shortly, probably 10, 15 minutes or so.
Okay, sounds good. Bye.
Bye. Okay. Okay, everybody see my screen? Okay, let's see here. So, systems quiz. So, we'll just run through these questions real quick. Just go ahead and kick it off here. Question number 1. What type of MEL restrictions are generally associated with the air conditioning pack system? Feel free to chime in, anybody that feels like they know the answer here.
Altitude restrictions.
Yep, that would be one.
Have a maximum altitude for one inoperative air conditioning pack is flight level 310.
Yep.
And maximum altitude for two inoperative packs is flight level 100.
Correct.
And possible cancellation of the flight.
Correct. Yep. Just depending on where you are attempting to fly, we don't generally. SkyWest does not generally operate the aircraft if both packs are inoperative. Ultimately, what that means is that the flight would have to be completely unpressurized, which is why you get the restriction of 10,000 feet if both packs are inoperative. So, did you guys go into any of the background? So, let's go back to the one pack MEL real quick and just talk about it for just a second. Maybe give you guys a little bit of insight. So, flight level 310 restriction for one pack inoperative. Any idea why 310? Is we just pull on that number out of thin air, or does anybody have an idea why it's that specific restriction?
It's the cabin pressure.
Correct. Yeah. Just to give you an idea, though, I mean, other aircraft, like let's take the CRJ-200. The CRJ-200, if one pack is inoperative, the flight level restriction is 250, so 25,000 feet. If CRJ-900, same thing, 25,000 feet. But the CRJ-700 is 31,000 feet, so 6,000 feet higher. And there's other aircraft, but they vary between 25,000 feet and 32,000 feet usually in there. But so the way that they come up with these restrictions as far as the flight level with one pack inoperative is simply, dude, there is a regulation out there which basically states that if you lose pressurization in an aircraft, the aircraft has to be able to has to descend down to flight level 140, I believe, is so 14,000 feet in less than, I'm not sure the exact time, but I believe it's either 2 or 3 minutes. If anybody knows that specifically, feel free to chime in. But anyway, the way that they come up with the restriction is that so you get the restriction of the flight level based on the aircraft performance in its ability to descend rapidly down to 14,000 feet or lower in the case of complete loss of pressurization. So when you have two packs operating, you obviously can go higher. We can go all the way up. The ceiling of this aircraft is all the way up at 41,000 feet. You lose one pack, and then it's 31,000 feet. So basically what this is saying is that the CRJ 700 can make it from 31,000 feet all the way down to 14,000 feet in 2 or 3 minutes in case the other pack also went out. Because once the other pack goes out, then you don't have pressurization at all. And then there's other things too. There's, other things happen in the air, like a few weeks ago where the Southwest plane had that engine failure, the uncontained engine failure, blew out that window. Something like that causes the aircraft to have what we call explosive decompression. So in those cases, the pressurization of the plane is lost immediately, completely wiped out. So in those cases, the aircraft has to make an emergency descent down to flight level 140 or lower, and that's just simply so that everyone on board can breathe. You'll have the aircraft or the oxygen mask will drop. You'll have to put those on and then get down to an altitude where you can breathe. So the restriction on this actually comes specifically from the oxygen mask. So those little things that pop out of the ceiling, those oxygen masks, they have little oxygen generators in all of those masks, and it provides enough oxygen for roughly 2 to 3 minutes of breathing. So that's really all you have with those masks. Once you put them on, is about 2 to 3 minutes of oxygen, and in that 2 to 3 minutes, you have to make it down to, like I said, 14,000 feet or lower in order to have regular oxygen. Enough concentration of oxygen just at an altitude where most people can breathe normally, and then obviously they'll continue descending even lower than that. But that's where these restrictions come from, specifically on this one. So it's basically the aircraft's performance capability of being able to rapidly descend within that 2 to 3 minute window down to 14,000 feet or lower. So
quick question, Adam.
It's
not like you can roll your windows down when you get to 14,000. Is there an exterior venting system to bring in outside air?
Yeah, so I mean, if that's basically what's being provided the entire time anyway, is you're drawing air from outside of the aircraft, to a certain extent, always to a certain extent, it's being drawn in. Once you're up at a higher altitude, the air, depending on the aircraft, the air inside of the cabin is actually recycled. And so, for instance, in the CRJ 700, up to about, I want to say it's up to about 75 to 80% of the air is actually recycled and basically blown back out. So a lot of people, once they realize this, they kind of become alarmed. Like, people always talk about how it's easy to get sick on an airplane, and people always, take airborne and all of those, anti-sickness medications before they get on an airplane because it's one of the most common places to get sick. Well, the reason behind that is because the air inside of an airplane, all that air you're breathing, is actually being just recycled, and it's taken back through the system and blown back out. So the guy that's up in the front coughing, all that air around him is going to be recycled and blown back out somewhere else. So there's only a few planes, like the CRJ 200, just as kind of an off example, is the air inside that aircraft is none of it is recycled. So all of it is drawn in from outside. So all the air you breathe in a 200 is I guess new, cleaner air. Whereas most other planes, though, it's recycled air. So, but they can have up to about 75%, I think, is the regulation of regenerated, recycled air inside of an aircraft. So, to a certain extent, there's always a little bit of air being drawn in from the outside, but once you get down below a certain altitude, like, depending on what the cabin pressure is, and, if you lost pressurization, obviously all of your air is actually being drawn in from the outside anyway. So, yeah, they don't necessarily have to get down there and, roll down windows or whatever because of that, because the bleed air from the engines, it's being sucked into the aircraft that way, is kind of what the science is behind it. Any other questions on air conditioning packs? Okay, let's go to number 2. What type of MEO restrictions are generally associated with the bleed air system? Anybody want to take a stab at that one?
Altitude restrictions, no icing, and it affects taking off.
Yeah. So bleed air systems, the primary one that we like to look at is going to be the anti-ice system. But yeah, the bleed air system as well. The altitude restrictions with bleed air system as well, because the bleed air obviously feeds the air conditioning packs, and so but it also feeds the anti-ice system. It also feeds the engine starting capabilities. All of that air, that bleed air, is used for a lot of different things. So, but the primary one, so any of those things obviously work as far as anti-icing, engine starting, altitude restrictions, pack restrictions, because the bleed air system does go into all of those things. But the one that we identify the most with the bleed air is going to be the anti-ice system, because that hot bleed air is what goes through all that tubing out in the wings, around the engine cowls, up into the tail section, and we use that air to prevent ice from building up on the control surfaces of the aircraft. Any questions on that one? Okay, let's go to number 3. What type of MEO restrictions are generally associated with the weather radar system?
No dispatching into hazardous weather or thunderstorms.
Correct. Yeah, so the big one there is going to be potentially hazardous weather, thunderstorms, anything like that. That's really the primary thing, is thunderstorms and any weather surrounding thunderstorms that you would need to be able to see on radar. So if you have a weather radar MEL, the rule, generally, even when the weather radar is working, we want to avoid thunderstorms as best as we can. When the weather radar system is out, we can still operate, obviously, with that MEL. However, if you have a lot and depending on what types of thunderstorms you're dealing with, but out in the western United States, where you get what we call a lot of pop-up thunderstorms, it's very, very difficult to operate anywhere that you have these random thunderstorms just kind of popping up out of nowhere. We're going to dive into weather starting actually today. We're going to start getting into it today. You're going to learn a lot about this stuff and how thunderstorms affect flying, and as well as a lot of different types of weather systems. But one of the big things we probably talk the most about is going to be thunderstorms. So in the summer, it is very, very difficult to operate any aircraft that has a weather radar system out of service or with a weather radar system MEL on your aircraft. It's nearly impossible. It usually grounds the aircraft and makes it unable to fly. Unless you just have a perfect day where there's nothing going on, usually that aircraft's going to be grounded. So yeah, the big thing you want to look at is thunderstorms, because even if it looks clear, you can take off and a thunderstorm can pop up. It is very, very difficult to forecast where a thunderstorm is going to suddenly appear and build up. So you'll learn more about that. But yeah, that is the big restriction with the weather radar MEL. Let's see here. Okay, number 4. What V speed is known as the takeoff decision speed?
V1.
Yes, V1 is the takeoff decision speed. Let's go to number 5. What is V2 speed referred to as?
Takeoff safety speed?
Yes, the takeoff safety speed. So basically, kind of just looking at both of those there, as you're rolling along the runway, you hit the V1 speed. V1 is basically the last point, okay? So when we talk about decision, you basically have to make the decision of whether you're going to take off or abort the takeoff prior to arriving at the V1 speed. And just because of the human mind, it usually is, when you make a decision, between the time that you actually make the decision in your head and you execute it with your hands or any part of your body that you have to move something or pull back the throttle or whatever you got to do, there's usually at least a 1.5 second delay. And you're going to see this once you get your licenses, and once you get on with an airline and you have to go out and do your initial jump seating familiarization flying. You'll go out, you'll see how the plane obviously is moving along at a very fast speed going down the runway. And in order to abort the takeoff, let's say if the V1 speed is 145 knots, if you're going to abort takeoff, you kind of have to know probably like around at the latest like 130, 135 knots in order to actually stop the plane before you get to the, or start stopping the plane before you get to the V1 speed. So once you pass the V1 speed, you have to take off. So just kind of going back to this real quick, the V1 speed is the last speed where you can safely stop the aircraft with the amount of runway remaining, like within that amount. So, you get all the way up to 145 nautical miles per hour, you're halfway down the runway. In order to stop it, go from 145 all the way down to 0, you need a certain amount of runway. And so the V1 speed is calculated based off of several different things, but part of it is the runway length to begin with. How much runway do I have to take off with, starting out? And, other conditions such as the temperature, the altitude, the elevation of the airport and the temperature and, the altimeter setting. So we'll talk a lot about those things as we go on. But all of those things together, there's a formula that we use to kind of punch in numbers to figure out the V1 speed. And once you hit that speed, though, if you go beyond that speed, it's going to be you're going to have to take off. And if you have some sort of an emergency or whatever, you still have to take off if you're beyond V1, and then you're going to have to come back around and land. If you have an engine fail or anything like that. So that's the takeoff decision speed. You need to know whether you're going to either take off or not take off prior to V1. Now V2, which is only a few nautical miles per hour higher than V1. Like if your V1 is 145, your V2 might be 150. Okay, it's usually very close, and usually from V1 to V2 is usually within a second or two. Like they're not very far apart. So once you get to V2, that's actually the speed, the takeoff safety speed. And so you're actually, capable of, the aircraft at that point is capable of lifting itself off the ground. It's going fast enough to create enough lift to get the plane off the ground. So, good. Any questions on V speeds? Okay. So number 6, name 3 different techniques that ATC uses to manage traffic congestion.
SIDS, ground stops, playbook routes.
Mm-hmm.
Ground delay programs, holding patterns.
Yep. Ground delay programs, holding, ground
Stacking.
What's that?
Stacking, miles and trail, minutes and trail.
Yep, miles and trail, minutes and trail. There's other things called metering programs. Lots of different. They have a lot of different techniques. They have SIDS and stars obviously help manage traffic congestion as well. Good. Sounds like you guys know a few of them there. What is the max takeoff weight of the CRJ 700?
£75,000.
Correct. Yes, 75,000 pounds. Remember, these weights are going to be something you guys need to memorize going forward. You're going to refer to them a lot. So yeah, 75,000 pounds is the max takeoff weight of the CRJ 700. So what is the max landing weight?
67,000 pounds?
Yes, 67,000. Correct. And number 9, what is the max zero fuel weight?
62,300.
62,300?
Yep, 62,300. Okay. Number 10, name 3 different sources of power for the CRJ 700.
IDG, APU, and ADG.
Yes. So which ones is what is the primary source?
The IDG is the primary source. The APU is the auxiliary backup, and the ADG is the emergency backup.
Correct. Very good. Okay. Number 11, name 4 primary flight controls.
Spoilers, rudder, multifunction spoilerons, ailerons.
Yep, ailerons, rudder, multifunction spoilerons. And so
Elevator.
are the spoilers a primary or a
Oh, I put spoiler in there twice. It should be elevators.
Yeah, so elevator, correct. So yeah, so aileron, rudder, elevator, and then multifunction spoilerons. Okay, how many hydraulic systems are there on the CRJ 700?
3.
3. How many pumps does each system have?
2.
2, you say?
2 pumps each.
Okay, good deal. 3 systems with
A and B.
2 pumps each. Yep, A and B. So how many of those pumps are engine-driven pumps?
2 are engine driven. Wait, maybe I'm getting that backwards. Let me think. 2 are engine driven, and all 3 Bs and 3A is electric.
Correct. Yeah, very good. Yep, 2 engine-driven and 4 electrically driven pumps. Yep. Just That must be the correct sound off there, huh? Cool.
Yeah.
What areas of the CRJ 700 are anti-iced using bleed air from the engines?
Leading edge of the wings and engine cowl.
Okay, I think a couple of you were talking at the same time there. What was that first one?
Leading edge of the wings
Uh-huh.
and the engine cowl.
Leading edge of the wings and the engine cowl. Yep. And also, there is another area. So up on like the rudder and the elevator, like the leading edge of the rudder and elevator as well. So that's another. Let's see. Okay. And then what are two primary functions of the APU?
To provide bleed air for startup and backup power.
Yep, bleed air for engine starting and backup power while you're on the ground. Okay, very good. And the extra credit question, what stages of the engine are used as the source of bleed air?
6 and 10.
6th and 10th. Good job. Okay, does anybody have any questions on anything? Nobody? Everyone? Pretty straightforward quiz for everybody? How does everyone feel like they did now that you know the answers?
Pretty good.
Wasn't too bad.
Nah.
I did well because of the review last night. Everybody chimed in and helped me.
Good deal. Cool. Okay. Well, good. Yeah. So just remember, you can get back in, or you can always retake quizzes and get back up to 80% if you don't get 80%. So just want you guys to know the material and get a lot of these any of these areas that you're struggling with. We just want you to get to the point where you guys need to be on any of them if you feel like you're behind on them. So okay, cool. So let's jump on to today's material. We're now going to transition into weather. Weather is definitely my favorite thing to probably talk about out of most of all of the topics that we discuss in here. Weather is probably one of the most fascinating. It has such a huge part in the job of a dispatcher. It's one thing that you're going to never stop learning about is going to be the weather. You can never know enough about weather theory, weather phenomenon, how it works, and not only that, not just the basic concepts of how weather works, but how it works in certain areas of the country. You're going to learn that, and I know a lot of you probably already know a lot about just where you've lived, throughout your lives. Different, I know several of you have probably lived in a lot of different areas, but you know that the weather is very unique to different areas depending on where you live, what the terrain is around where you live, the climate for where you live, elevation. All of those things play a huge factor. How close you live to bodies of water, to oceans. All of those things play a very, very important role in how weather develops in certain areas. And with the dispatch environment, and just as the SkyWest example, but depending on which airline you work for, you're going to have hundreds of different airports that you will operate aircraft into, that you're going to be dispatching airplanes into, and every one of those airports is going to be unique to its own weather to its local weather patterns. So it's really a never-ending process on learning about weather and how it develops in certain areas. One thing that like meteorologists, as they if you go into meteorology, or if you go into anything weather related where you are developing forecasts or weather reports for certain areas, it's really unique to where you live. And people, you can have weather experts for certain areas that are signed off to be able to give weather reports for, let's say the St. George area as an example. But, if you take that same person and put them out in Texas, they're not going to be able to forecast weather as easy, because, each type of meteorologist has to basically get certified for the area that they are over and that they're working with. And as a lot of them move around and work in different areas, they have to get signed off and certified for being able to forecast weather in whatever area of the country that they want to work in. So it's very similar for dispatchers, though, as well. It's not that you have to go officially get signed off, but what I can tell you is that dispatchers pretty much become almost secondhand meteorologists in a way. And you're going to notice that dispatchers become, especially those that really get into the weather and really embrace weather, I guess, and embrace learning about weather, will become very, very good weather forecasters themselves. Not that they can officially issue a forecast by any means, but you're going to notice that as you gain knowledge in weather and gain experience dispatching into certain areas of the country during certain times of the year, you're going to be able to predict weather in a lot of cases better than even the meteorologists will predict weather. So in a way, sometimes you will actually get weather reports for an airport that you're sending a flight into, and you'll look at the weather report, you'll look at the forecast, and with your knowledge and with your background and with your experience, a lot of times you will actually second guess what you're seeing, and you'll know when you're getting really good at the weather stuff, because you'll start to not trust weather in certain areas. You'll start to learn that, the weather guys in Denver are not very good at forecasting thunderstorms or whatever, and you'll actually start to make plans in your own head and fuel your aircraft and plan accordingly, because you don't necessarily trust the weather forecast. You think you'll end up thinking something else is going to happen than what it dictates in the forecast, and a lot of times you'll find out that you'll become justified in your reasoning, because you'll be right a lot of those times as well. So yeah, I just want you guys to know, before we start getting into weather, it's a huge thing. I mean, and the thing is about weather as well is that there's still so much unknown about it. When you talk about thunderstorms, tornadoes, all of the big weather phenomena type stuff, there is still so much to be known about that. Still so much that's out there that we don't know, that we can't predict. And even from when I started dispatching, there's been huge advancements just in the past 10 years of what we can see with weather, and what we couldn't see even just 10 years ago. I can't believe some of the stuff that we have now. To think that they've been dispatching airplanes, 30 years ago with very basic radar technology, it's just, it baffles you to think that, what you have now, like to think that you didn't have it back then, some of the stuff we have now, you wonder how they got around and how they were able to do it. So, yeah, but I mean, you look ahead, what are we going to have in 5 years? What are we going to have in 10 years that we don't have today? And it's going to be, really good stuff. And weather is just one of those things that's just advancing, at a very fast rate. There's so much to learn, so much to know about it. You'll never stop learning about it. It's going to get to the point where it's just one of those things where you just, it's really never ending. So I just want to invite you guys to just embrace weather, learn as much as you can about it. It's going to be one of the biggest things that's going to help you be a good dispatcher. And it's going to be one of the things that the more you know about it, the more you're going to be able to help in certain situations, not only other dispatchers, but the flight crews that are flying your airplanes that you dispatch, emergency situations, diversions, all of those types of things. The more you know about the weather and the more you know how to plan according to the weather and what you're seeing, the more you're going to avoid situations that are going to cause you a lot of extra work as a dispatcher. So yeah, just really grasp onto this weather stuff and run with it as much as you can. I believe you guys already got on here and watched this little video link. Is that correct?
Yeah.
Yeah? Anybody not watch the video? Anybody?
I didn't watch the video.
Okay. Well, just when you get a chance, just anybody who hasn't watched it, when you get a chance, get in there and watch it. And there's actually a lot of videos throughout the weather section that you're going to be able to see. Very informative stuff. I'm not sure how many of you guys like the Discovery Channel, National Geographic type, documentaries about different things. But like we watch, there's a lot of them that we have links to during this section that are really good. They're just really good videos to watch. A lot of the feedback we get over the classes, in the past have been like, oh, that was one of my favorite things, and send me more of those weather videos, send me links or whatever you have. If you have extra stuff, people just kind of eat it up, which is good. That's what we want. We want you guys to kind of be seeing as much of this as you can. So, okay, so let me bring this up here. Okay, so one of the very first things that the very first thing we're going to talk about here with weather is just understanding basic weather theory, why we have weather, where it comes from, why it even exists in the first place. You got to have that basic understanding of how it even happens in the first place, and why it's so unique to different areas on the planet Earth. As far as just to kind of take the temperature of what you guys know regarding weather, has anybody taken any weather classes or know much? I mean, how do you guys feel overall your general knowledge about weather is?
I can tell when it's raining.
I understand mountainous regions and how landforms affect weather. I do not understand why the area around Dallas-Fort Worth is chaotic.
Chaotic as far as like thunderstorms?
I feel like Dallas literally gets everything. They get ice storms, they get tornadoes, they get humidity, they get wind.
Yes.
You name it, Dallas gets it.
Yeah.
Why?
Yeah, no, you're correct. It's primarily, you'll learn about that entire region, like really the entire Midwest, from Dallas into Oklahoma, Kansas, that whole Tornado Alley area. You should be able to understand exactly why that area of the country gets such adverse weather. But yeah, you're right. If it's not one thing, it's the other. If it's not tornadoes during spring and summer, it's ice storms during the fall and the winter, right? So I mean, yeah, it is. It's no rest. And believe me, I've spent 8 weeks this year in Oklahoma City already. So unfortunately, that's where the FAA Academy is, and so we have to spend a lot of time there training and other things. But I went there I was there from like February, the first week of February, all the way until mid-March, and saw all sorts of different weather. And I'm going back there in about 3 weeks, and I'll be there the entire month of June. So it's I'm pretty sure going to see pretty much everything. We saw ice storms and all sorts of stuff, back in February and March, and probably see some tornadic type stuff coming up here in June as well. So kind of looking forward to it in a way, but not looking forward to it. I don't like to necessarily be there for a lot of that type of weather. It's kind of more cool to just see from afar. But anyway, we'll see how it works. But yeah, so generally, what we first need to kind of jump into is just why the Earth, and why we have all these different weather patterns everywhere, and understand what's affecting it, what's driving all of this weather change, and all this stuff. So the basic idea is, first of all, just understanding just the basics of the Earth, right? So the number one thing, the common denominator behind all weather in general is the very first ingredient in all of this whole thing is going to be the sun, okay? So the sun, first of all, is going to be our number one thing that is affecting the Earth. And everybody kind of knows how the Earth is. And, obviously we know we got day, we got night, we got different seasons, we've got winter, summer, fall, spring. We've got all these different things. The Earth is tilted, and depending on where you live, and what time of year, you're going to be cold, you're going to be hot, all of these different things that are affecting this. So the very first thing is that we have the sun, the Earth rotates, all common things that we all know, we've known forever. However, so the sun, as it heats up the Earth, it's heating it up, but it's all uneven. So you have kind of going back to the seasonal stuff, the tilt of the Earth. So the sun is constantly heating the Earth, but that heat is always uneven. It's always warmer over here, colder over here, and daytime, nighttime, and then the change of the seasons, obviously. But it's the common denominator in all weather patterns is the uneven heating of the Earth's surface. That's something you guys are going to want to know. So write that down. I'm positive that it's going to be on the quiz, just as kind of your basis of all weather. Your creator of all weather is going to be the sun and the uneven heating of the Earth's surface. Okay. So what happens with that uneven heat is that when you have a hot area and then cold areas, that is actually the thing that starts to drive your wind patterns. So we have an atmosphere, which is another thing. So you have the sun heating the water, we have the sun heating the atmosphere. And so when you have warm water or warm air, and then in one area, and then you have cooler air or cooler water in a different area, what happens is the atmosphere and like the wind in the atmosphere gets sucked in and sucked towards these these hotter, areas and these colder areas. And that's ultimately what creates all of our wind patterns on Earth. Is same thing. It all goes back to the uneven heating of the Earth's surface. One really basic thing, like if you just kind of want to look at it and kind of look at, let's talk about like the coast, like the California coast, just to kind of give you kind of a basic idea of how weather is working, like on a daily basis. So, I'm sure, has anybody here not ever been to the ocean or not ever been out to the coast? Anybody? Okay, so I'm assuming everybody's been to the beach somewhere. And what's one of the common things that if you're by the ocean, that you almost always have? and you know, it's going to be common of any coastal area. You almost always will have a breeze, right? Does everyone associate the beach and the coast with a breeze? Anybody not? So one of the
Absolutely.
Yeah, exactly. So it's one of those things that always exists when you're by the ocean, essentially, or if you live by the ocean, you always have these breezes. So what happens, just kind of give you an idea of like the uneven heating, right? So what normally happens in a coastal area was, let's talk about it from the very beginning of the day. As the sun comes up, what happens is the sun will come up and it will begin to heat the water and obviously the land. So you have, on the coast, obviously the land meets the water. That's where the beach is. Everybody knows that. But as the sun is coming up, as the sun rises during the day, it starts to heat up all of the area, and it starts to heat up the water, and it heats up the land. So the thing about land and water, though, is that land heats up at a lot faster rate than water does. It takes a lot longer to heat up a body of water than it does a section of land. Okay? And so what happens is as the sun is doing that, it creates this uneven heat, right? So you have the ocean meeting the land. You have, if it's during the day, it'll be a cooler ocean temperature because it can't heat up as fast, and then it'll be a hot land mass. And because those two things have an uneven temperature, it creates a breeze. And so what normally happens is the air likes to travel from wherever it's cold into where it's normally warm. So actually, sorry, that's the reverse. I had that backwards. So the air, if it's during the day and you're out at you're on the beach, typically what's going on is the air is going to be blowing out to sea. Okay, that's usually what happens as the land is warmer than the ocean. Then it normally creates that breeze going out to sea. And then what happens at night as the sun sets, it's just the same idea. The land cools a lot faster than the ocean will cool. So then you'll get an inverse effect. The ocean at that point will be warmer than the land because it cools down a lot faster. And then that breeze will flip-flop, and it'll be then a sea breeze coming in off the ocean onto the land. And so that's why the air moves around, and that's why there's almost always a breeze when you're on the coast, because you have a huge body of water which cannot heat up and cool as fast as the land, and because of that, it's almost always going to create a wind drawing that air in and out. And as the sun comes up, it'll shift, and the sun goes down, it'll shift back. But it's like clockwork out on the coast. So. But that just gives you a basic idea of, and that's just on a local level, obviously. But that's just kind of showing you the whole idea. But that whole idea is obviously global. When you look at it on a global perspective, you have big oceans that are warmer than bodies of water, and then that whole thing is driving all of the global weather patterns that we have. It's what drives hurricanes during the summer fall season. It's what drives monsoons and tropical storms. It's anything that we have that you see, you can usually explain it down to ultimately it being the uneven heating of whatever section of the planet it's occurring on, and then you can also drive it into which way what time of year it is and what area, like how that water is traveling. You can get into this a lot more, and you start talking about ocean currents and the warm water from the equator and how it travels up and goes up different coastlines, and you have cold currents, warm currents, but all of that obviously is driven by the uneven heating of the Earth's surface and how it carries that water around. Another good example of this, obviously, is the Pacific coast of the United States. So you have California, once again using the example of like the West Coast here. The California. So let's just pose a question here real quick. So I know most of you have probably, I guess, been out to the California coast. How many of you have been up to the Pacific Northwest coast, Oregon, Washington area?
Yes.
Yes?
I have. Yeah.
How different is it than, say, the California coast? Talking about like, Los Angeles, San Diego, those areas. Like, what's the big difference between that and, say, Portland, Seattle? As far as climate.
It's more, well, the climate's just more rainy and colder climate. It's not that warm summer breeze that you get down in Southern California.
Mm-hmm. Yeah, and the big driver behind all of that is going to be your ocean currents. So another big factor, obviously, of weather patterns is going to be ocean currents. But once again, the ocean currents, whether it be you have two basic currents. You got warm currents and you got cold currents, and depending on where they are, traditionally the Pacific Ocean, from coming up through Mexico and up into Southern California, up even into Central California, almost pretty much up to even into Northern California, you have a big Pacific cold current that travels up the west coast of Mexico and the United States. And that cold current goes all the way up, and it goes up right into about Northern California, and then it takes a dramatic turn to the left, and it goes out to sea. And at the same time, there's another huge warm current that we have that it's a big warm current that actually travels from the equator. And wish I could bring up a chart. I could probably find one, but just to explain it a little bit easier, it's a big warm current that actually travels all the way up from the equator, and it goes up through the Pacific Rim area. So when you get Pacific Rim being like up through the Philippines, Japan, a lot of those areas, and it curves all the way up, and it goes actually up into Alaska and down through like the inside passage of Alaska, down through Canada and down to Seattle and Oregon, into those areas. And then, so that's a big warm current pattern that's actually coming down, but it actually does a huge circle. It circles up from the equator, up through the Philippines, Japan, up to Alaska, down the west coast of the United States, as far south as about, Oregon, really. And then at the same spot that that current, it kind of hits into that cold current that's traveling north up the other current that I started talking about, but up north, and they both kind of go out to sea at that point. So you have two totally.
I just posted.
Oh, you've got it in there?
I just posted a link so you can see that chart or something like it.
Yeah. Okay, yeah. Yeah, exactly. So let's see if I can get I guess that's probably not going to go very much bigger there. But yeah, you can kind of get an idea if anybody wants to click on that link there and bring it up. But but that's what drives a lot of that weather. So when you have a cold current, you're not going to have a lot of rain, because the evaporation and everything else of the water is not going to, it's not going to create a rainy environment. So when you're talking about California, and especially Southern California, you have mostly desert landscape. You don't get a lot of rain. That's why a lot of people like Southern California, because it doesn't rain very much, you've got the beach, you've got typically pretty good weather. But once you get up into Oregon and Washington, you get into very rainy areas, and that is because the water off of the coast of Oregon and Washington is really warm water, and it creates a lot of evaporation up into the atmosphere, which obviously is going to create a lot of rain. So these are just, I'm just really just touching the surface on this whole theory about, the warm and cold currents, and then, obviously those come from the uneven heating of the Earth's surface. But this kind of just gives you these ideas. If you really want to understand weather and why it is in certain areas, most of it's going to end up coming from ocean currents and wind patterns, obviously, in those specific areas. If you have wind that's moving over an ocean current of a warm body of water, it's always going to be a rainier area, and so you can really dissect why you have that huge transformation from California being dry and little rain, and then Oregon and Washington being very rainy. So pretty starkly different areas. It also, if you dive into even more stuff as far as like how, like what areas are better for like fishing and things like that, and where you see more, like industry as far as like fishing and whaling and all of that kind of stuff, it's usually always driven by the ocean currents as well. So on the east coast of the United States, you have has anyone ever heard of the Gulf Stream current? The Gulf Stream current is a big warm current that goes up the eastern seaboard of the United States. Now, the only issue out there is that the prevailing wind pattern for the lower 48 states is always going to be from west to east. And I know that you guys have seen weather reports and you've watched the news, you see weather. It moves from the west to the east, typically, right? As a general rule. Now, not to say that it can't, go a little bit northwest, or sorry, like move northeast or southeast, and on different times of the year. But as a general rule, the weather and the wind moves from west to the east. So we have a huge warm current that goes up the eastern seaboard of the United States called the Gulf Stream. Because the wind is coming from the west to the east, it doesn't really affect us very much as far as weather goes, because our weather is moving from land over the sea, and once it hits that Gulf Stream current, it carries that weather out to sea, instead of where you look at the western United States and up in Seattle, that the weather is moving from the sea over the warm water and then onto the land, and causing a lot of those weather patterns. So, but it does affect other things, like when you look at like the hurricane season in the United States. You look at the pattern of like the Gulf Stream currents and those currents that come up from the equator up into the United States. Let's see if we can pull up. So this is, I'm going to try to see if I can get a little bit of a bigger, doesn't look like that's going to help me there. But anyway, yeah, so like, a lot of our hurricane issues that we have during the summer and fall seasons are driven by the Gulf Stream currents. A lot of times, I'm not sure how well you guys can see this on your computers, but you get a lot of hurricane formation down here along the equator in the Atlantic Ocean, and it moves right up. It pretty much follows the Gulf Stream current right up into the Caribbean area, Puerto Rico, Florida, Cuba, and then up along the eastern seaboard. It follows that Gulf Stream current a lot. So, but you can actually get in if if you're interested in weather and you're interested in how and why we get the severe hurricanes that we do. You can figure it out really easy just by studying ocean currents and the heating of like what areas of the water are warmer, colder, and the wind patterns and how everything works. And it's pretty fascinating, you know, at least for me. Like, I really like looking into that kind of stuff. So anyway, let's get back to this. So we've got all of this uneven heating of the Earth's surface, moving around, moving the weather. It's causing all of the different types of weather systems all over the planet. So just kind of looking at, so this section here, this document that we have up here is a document that was produced by the FAA. It's what's called an advisory circular, and it's produced by the FAA in order to, you know, for people in the FAA and you know, that have airline type positions to be able to study about weather. So we actually assign, you know, part of this class is you're going to read through a lot of this document here, but it goes through a lot of different weather patterns and a lot of different, you know, weather theory topics. So you're going to get to know this quite well here. Let's see, global circulation, the sun, weather. Okay, just kind of seeing where I'm at here. So let's see here. Let me move down just a little bit. So going back, talked about how the Earth is unevenly heated. So the next thing it kind of dives into is it talks about the rotating Earth circulation. You know, saying here that the Earth rotates, the axis of the Earth is tilted, and there's more, you know, during certain times of the year, there's more land mass in the northern hemisphere than the southern hemisphere, and it makes the global pattern a lot more complicated. So what ends up happening is, you know, it's basically saying there's a lot more land north of the equator than there is south of the equator. So when we're in our summer seasons, we get a lot more adverse weather because the overall temperature of the Earth is higher because there's a lot more land. And like we were talking about earlier, land heats up a lot faster than water does. And it complicates a lot of the global weather patterns. So a lot of these things dive into talking about like a Hadley cell and these Ferrel cells. A lot of this stuff isn't necessarily stuff that you have to know a lot about. So the big things that you guys need to know regarding weather theory is really just the basis of it, saying like when we, you know, like the very basics, talking about like the quiz question that I was already told you guys you need to have memorized there. Just the uneven heating of the Earth's surface is what causes all weather patterns and wind patterns on Earth. So we don't dive it. We will talk a lot about, you know, additional weather theory topics, but some of the stuff we dive into here is kind of stuff that's above and beyond. It's not, you know, you're never going to refer to Hadley cells and Ferrel cells and different things that we do kind of briefly touch here. But a Hadley cell is a low latitude air movement toward the equator. That with heating, it rises vertically with poleward movement in the upper atmosphere, and it forms a convection cell that dominates tropical and subtropical climates. And then a Ferrel cell is a mid-latitude mean atmospheric circulation cell for weather named by William Ferrel in the 19th century. Once again, you don't need to know any of that. But air flows poleward and eastward near the surface and equatorward and westward at higher levels. So it basically is talking about how these cells, these big cells, will create kind of all of the Earth's surface. And then there's also another type that's called a polar cell, and it's just air rising and diverging and travels toward the poles. Once it's over the poles, the air sinks, forming what we call polar highs. And at the surface, the air diverges outward from the polar highs, and surface winds in the polar cells are usually easterly. So the reason that it's kind of talking about these different cells that we have all over the place is because those cells, those global cell systems will drive a lot of weather. It's also what causes, if you can see this diagram here, if you look at the United States in this diagram, let me see if I can kind of get my little highlighter out here. But in this area here, you see these arrows are kind of coming up from the south, and then they turn and go east. This is representative of our wind pattern for this section of the Earth. So between this yellow line here and this one up here, it's basically telling us that the wind pattern in that area is generally from the south or from the southwest to the east or northeast. And that's caused because of those Hadley cells, those ones that we were, the different cells that we were already talking about. Now, once you, when you get into like the winter time, and you're going to see this a lot as you learn more about weather and as you dispatch and stuff, but like during the winter, what will happen a lot of times is we will get these big polar air masses that get stuck up here over, the Arctic Circle or over northern Canada, and a lot of times those polar air masses will start to diverge down southward into this area of kind of our area here in the United States, and it'll disrupt the pattern that we have for our general weather pattern, which, like we said earlier, is west to east. And so a lot of times you'll see, and maybe, I don't know if any of you have ever lived in the northern Midwest area of the United States, but during the winter, you can get, when you get these polar, what we would call, like I said, the polar air that moves down over Canada, you get, what happens is you get this air that'll be kind of sucked down over the United States, and it is extremely cold air, and it'll cause the Midwest, especially like Minnesota, Minneapolis, some of those bigger cities, Chicago, a lot of, the upper Midwest areas, it'll just cause absolutely frigid temperatures, negative, all the way down -20, -30 degrees for a week or two or three at a time. We had a little bit of it last winter, and you always get a touch of it almost every year. And sometimes it's more extreme and sometimes it's less, but it's kind of, if you want to learn more about it, it all derives itself back to these air masses that get stuck either up here over the polar region, and then, coming down into depending on how big they get, they will sometimes converge into these different areas. But when you look at this, what this diagram is trying to depict is the general circulation of the Earth's weather pattern. So, and like I said, it's a general rule, and sometimes it gets disrupted during different times of the year, depending on, how cold air gets to the north and how warm air gets to the south. So let's see here. So this is kind of talking a little bit about low pressure bands and high pressure bands, and the characteristics between like a low pressure system and a high pressure system. So it says usually fair and dry hot weather is associated with high pressure systems, with rainy and stormy weather associated with low pressure systems. So just as a general rule, when you talk about a high pressure system, it's usually good weather, warm weather, dry, and when you hear about low pressures, it's usually going to be rainy, stormy. In the winter, it's like where you'll get your snowstorms and things like that as well. But these circulations result, they become evident on a global scale. It talks a lot right here about like the deserts the location of deserts. It says consider the number of deserts located along the 30-degree north-south latitude around the world compared to the region between 50 degrees to 60 degrees north-south latitude. The higher latitudes, especially near the west coast of continents, tend to have more precipitation due to more storms moving around the Earth at these latitudes. So you start to look around and kind of see the location of deserts around the globe and rainforests and things like that. And it all drives itself back to where your warm water is located and what the weather pattern is in that area. If you go back a little bit, let's go back up to our little graph up here. If you look at the weather, like if we go down into South America, and I know you can't see it very good on this picture here, but in South America, in the Brazil area, well, really most of South America, you have a huge rainforest there, the Amazon rainforest, the Amazon River Basin, all the way through Brazil. And it kind of goes back to the same, the reason it's a rainforest is because down in that area of Earth, the weather, the general weather pattern is from east to the west. So your wind actually moves from the Atlantic Ocean, where it's got nice warm water over the Atlantic, and it moves from the east over the continent of South America and just drops all that rain into the Amazon basin. But it's because it's backwards. It's like up here in the United States, it goes the other direction. It goes from west to east. And we don't have any rainforests here in the lower 48 United States. And that's because our general weather pattern is coming from a cold weather or a cold water source over our continent. But down in South America, it's the exact opposite, going from a warm water environment from the east over west over their continent. And then their drier areas, once you get on the western seaboard of South America, it's a lot of desert along that west coast. You have actually the driest desert in the world is that west coast of Chile, the southwest coast of South America. So, but once again, it's all because of cold currents and wind patterns. So let's talk about tropical weather. Saying here, technically, the tropics lie between the latitudes of 23.5 degrees north and 23.5 degrees south. It says the weather typical of that region sometimes extends as much as 45 degrees from the equator. Generally speaking, when you talk about the tropics, and for anybody that's been down into the tropics, if you travel down to that area or go anywhere, you typically don't have seasonal change in the tropics. You don't really have, we generally think about it as being rainy, rainforest, stuff like that. But generally speaking, it's normally going to be warm. You don't have a lot of seasonal change, and, typically warmer weather year round. And it's kind of interesting about the tropics because it contains both the wettest and the driest regions of the world. So this part here describes the basic circulation over the tropics, and the terrain influences what areas are arid and what are wet. But going back to those driest areas, the areas of like South America that we just talked about, or if you go over to Africa and talk about like the Sahara Desert area, it's in the tropics, and it year-round higher temperatures, and if it doesn't have a warm water source, either directly in front or of its general wind pattern, then it's going to be either extremely dry or it's going to be extremely wet. So, same thing with, when we were just talking about the Amazon rainforest area. So the overall idea here is just to kind of understand the basic weather patterns, global weather patterns, and kind of know like why this area of the earth is a rainforest and why this area is an extremely dry desert. But it's really just, once again, it's just all kind of goes back to these, the warm water and your wind patterns. So I try not to get too much into this. If you read through a lot of this information, it really starts to dive into a lot of additional stuff that's not necessarily pertinent for people going into dispatch to know about. So I tried to kind of sift through, really kind of hit on the stuff that's more pertinent for you guys to know about. If you want to learn more about it, you can obviously circle back and you can actually read through all of this word for word if you'd like to. But trying to kind of zoom through here and cover some of the better, more pertinent stuff that you'll want to know about. Let's see here. Okay. Tell you what, if you guys would like to take, probably been going for a little bit here. If you guys want to take a 15-minute break real quick, and I'm showing 8:21 on my clock. Take until about 8. Let's just call it 8:35, and we'll jump back on here. Give you guys a break here for a minute. Okay, is everybody back on?
Yes.
Good deal. Okay, well, let's continue kind of diving into this here for a little bit and take a look at a little bit more basic weather theory going on. So these charts here that we're looking at are the average worldwide surface pressure distribution and prevailing winds. So these two charts are kind of a comparison. It's looking at like how the general weather patterns are in the month of July, and then how they are in January. They do change a little bit, obviously, and once again, that's all driven due to the where the sun is and what it's heating up and what's cooling down. But if you look at the general weather patterns in July, let's just take a look at the continental United States. You can kind of see that out to the west in the Pacific Ocean, there's a big high pressure system out there that kind of likes to sit out there. And then you have a low pressure system over there of the southwestern United States. And out to the east, you have another high pressure that's out there over the over the Atlantic Ocean. If you look at those little arrows, I'm going to kind of try to zoom in here a little bit better so you guys can see this good. Kind of see these little arrows. These are your general wind directions. So during the month of July, one thing you'll kind of notice is that you get, if you notice this air up here coming out of Canada, it kind of comes and it's traveling southeast into the United States. And then you have another wind pattern down here coming off of the Gulf of Mexico that is basically going mostly north, but a little northeast coming off of the Gulf here. So one thing I kind of wanted to help you guys notice here, I'm going to talk about two different things. First is back when I said, back kind of at the beginning of talking about weather here, I was talking about this section of the country here, this Midwest section, your Tornado Alley area, which is kind of trying to draw in right there. So this section of the country during the months of, well, really April, May, June, July, you get a lot of, your tornado season essentially is what goes on like this time of year and all the way through July. But it's really driven because of these wind patterns that you see here. You get this cold wind coming down out of Canada, and you get this warm wind coming off of the Gulf of Mexico. And what happens is, so the Gulf of Mexico is really warm water. And when you get that really warm water, the Gulf of Mexico produces a lot of evaporation into the atmosphere because it's a huge warm current that really goes all the way through the Caribbean and goes into the Gulf of Mexico. If any of you have ever been to anywhere along the Gulf Coast of the United States, whether it be, Texas or Louisiana, Mississippi, the Gulf Coast of Florida, the water over there, I mean, some of the best beaches you'll ever go to, and the water it's like walking into bath water. It's extremely warm water. But that water, it really drives a lot of storms. And during those the warmer months of the year, the general wind pattern goes from the south to the north, and it carries a lot of moisture off of the Gulf of Mexico into the southeast United States and up into the Midwest United States. And what happens in those areas in the Midwest, Kansas, Nebraska, Oklahoma, northern Texas, Arkansas, Missouri, that's your tornado alley. And the reason why you get such bad weather is because that air system, that the cold, dry air coming from Canada, it basically slams in to that warm, moist air coming up off of the Gulf of Mexico, and it meets right in that area, that tornado alley area, is where those two weather systems typically end up colliding into each other. And when you have cold, dry air slamming into warm, moist air, it creates, that's what really, that is your recipe for thunderstorms right there. That's why that area of the country gets a large amount of tornadoes, really bad thunderstorms. And the big thing about it too is that it's an unprotected area. As far as terrain goes, you notice that wind pattern coming out of Canada, it's to the east of the Rocky Mountains. If you were to draw a line, you can kind of see it. This has an outline of the terrain there. You can kind of see where the mountainous area is, but the Rockies is really this area, or the mountain there. So the reason the wind pattern is the way it is because it travels out of Canada and it stays to the east of the Rocky Mountains over that flat region of the country, and it goes right down to where just unprotected, cold, dry air coming out of Canada and that warm, moist air coming up off the Gulf of Mexico. Once again, flat land, nothing to disrupt the airflow. It comes right up off the Gulf, no terrain to be heard of, and those two systems, they slam right into each other, and it creates a lot of convective weather. That's where get all of your thunderstorms, all your tornadoes, and most of your adverse weather. And then in the obviously for the same reasons, when we look at the January slide, you can also kind of figure out just by looking at the wind patterns and knowing where that wind is coming from, and if it's coming off of warm, moist, bodies of water or dry land, you can develop your own recipes and figure out why you have any type of weather anywhere you look around. Those of you guys that are from St. George, and have lived there for a while, you know that, obviously this time of year, you really start heating up. Have you guys already kind of been in? You guys have already been into the hundreds already this year, haven't you? Have you guys had any triple-digit days yet?
Not the 100.
We have in
Not yet.
Mesquite.
Yeah.
Yeah.
So obviously, if they haven't happened already, it's right around the corner, right? So like June and July I hated being there in June and July. However, one of my favorite months of the year of living in St. George is always in August, and it's almost like clockwork. That last week of July, and it's almost, one thing that I always noticed, and the thing is I always really tried to pay attention to it because, just being in dispatch and studying weather so much, you kind of do that stuff automatically. But I really paid attention. But it was almost like as soon as August 1st rolled around, it was like a light switch that it just turned on that the rainy season. And August you would think should be one of the hottest months of the year for St. George, but you get so much monsoonal rain in the southwestern United States that you have a lot of days that cool down a lot because you get a lot of rain, and you get the thunderstorms rolling through, and it's very common to have an entire week where you get thunderstorms all week. But it's because of what's going on. If you really want to figure out, and if you're someone that's grown up in St. George, and you kind of, just by growing up there, that when August rolls around, you get those monsoonal rains, the rainiest time of the year typically. And it's kind of nice because you come out of June and July where it's so hot and you get like zero rain in June and July, and then it's usually a welcome rainstorms coming in August. But if you've ever done more than other than just knowing there and living there and knowing that it's going to happen just because you've experienced it year over year, if you've ever done more than that to figure out why it happens, you just take a look at some very, very basic things of what's going on out in the Pacific Ocean that time of year, and why do we suddenly get that uptick of rain that just suddenly decides to come in August. And you start to look around and you can kind of see, you look to the southwest, out over, off the coast of Mexico, and big areas of water out there they start heating up, in May and June, but it literally takes a couple of months for those bodies of water, the Pacific Ocean out there, because it's a cold current area, and it's cold water that's normally going through there. But once you get the sun up into the northern hemisphere and heating up all that water, starting once you hit spring, and so it starts heating up April and May and June. But by the time you get through July and you start to get into August, or the end of July really, the water in the Pacific Ocean has had enough time. It takes months. This whole process takes months to create the monsoons. But by the time you get to the end of July, it's finally warmed up enough in the Pacific Ocean that the water starts to become a lot warmer than it is in, say, May or June. And because of that water temperature, you get to a point where the water is at a certain temperature where you get a lot more evaporation into the atmosphere. Well, that evaporation ultimately, and that warm water, is going to cause a shift in the wind pattern. And what happens is you start to get all that evaporation, and because it's warmer, and then if you get areas of the landmass, which, especially like at night where it cools down a lot, and then you have now a really warm ocean out there, just during that time of the year, you'll get that wind pattern. It'll shift, and it'll actually seasonally shift the entire wind pattern for that area. And that's where, when August rolls around, the southwestern United States starts to get those southwestern winds where they come up, and like in California, they'll call it like a Santa Ana wind. But you get that wind coming up, and it's bringing all that moisture and that warm current, all that evaporation and that warm water off of Mexico, and it's bringing it up right into the southwestern United States, and it just dumps rain all over the Southwest for, August and September. So it's just a seasonal thing that happens, and it's really just because of the heating of the ocean, off the coast of Mexico, and it changes everything. Because of that warm water, the wind will shift, and then it'll draw all that moisture up into the southwestern United States, and it's like clockwork. It literally is. August 1st rolls around, and then you can almost bank on the rains. The rains will be coming. So, just for those of you that grew up in St. George, if you didn't know why it was that way or why we always got that, that's your brief explanation for it. And then talking about that Midwestern United States. The tornadoes, there's reasons behind all of this. And if you want to understand why you have certain weather patterns in certain areas of the country during certain times of the year, you can really quickly figure it all out just by looking at, the heating elements, the warm water, where's the warm water and what's the wind doing that time of year. And it'll explain every last thing for you. Let's scroll down and take a look at what the weather patterns look like in January. Oops. Okay. So this is the prevailing systems for January. So if you compare it to the way it looks in July, a little bit different. You have more of a high pressure system that actually sits over the southwestern United States, which causes the winter months to be really dry, and it keeps a lot of that moisture out. And then obviously, the sun during January is primarily going to be in the southern hemisphere. And so you don't get heating of the water. You don't get that, that monsoonal effect that we just talked about in the Pacific Ocean. It's not, the sun's not up here heating up any water off our west coast. And so it's really colder water, which creates a drier environment. Most of your wind is coming, still off of the ocean, but it's not carrying any moisture because there's no evaporation, which in turn is not bringing us really any snow or anything else. The only time we really get snow is when you get this, you kind of see the low pressure that's hanging out over here in the the northern Pacific Ocean. It draws a lot of this moisture, and sometimes this, depending on the timing, in winter, and like the thing is these are your prevailing dominant weather patterns. However, it's not to say that these don't ever change, because occasionally they do change. Like you see that you have this high pressure system here, which normally it's going to draw the wind from the southwest. Now, when you take a look, just to kind of talk a little bit more real quickly about high and low pressure systems. With a high pressure system, the wind, if you can kind of see this here, like this, you can see this low pressure system up here. The wind always travels around a low pressure system in a counterclockwise pattern. Okay, so it's always circulating counterclockwise around a low pressure. In a high pressure system, it is exactly the opposite. High pressures, the wind circulates clockwise around high pressures, okay? And why do we care about that? Well, it's because it'll help you really figure out what winds you're going to get. It'll help you figure out, why am I getting a south wind today? Why am I getting a north wind? And depending on the winds, I mean, it is the primary element that actually helps meteorologists forecast what the temperature is going to be. because if the wind is, in the winter, if you're getting wind coming out of the northwest, then typically you're going to see colder temperatures and you're going to see moisture. If you get the wind coming out of the southwest, then it'll usually warm up a little bit. So like in the middle of winter in St. George, sometimes we have really cold days and sometimes we have warm days, for a winter, like in St. George, a warm day, obviously in the winter, 50 or 60 degrees, we could sometimes get up to. But that's only going to happen if in the situations, St. George stays generally mild during the winter, and that's because the prevailing weather pattern is going to be this high pressure system that sits out over the Pacific Ocean. And what it does is, because it's a high pressure system, it's bringing up this air, and it's really all dependent upon the location of where the high pressure system sits. And you can see that because it sits here and then you have another high pressure that sits here, it helps draw this clockwise motion wind pattern. It's drawing up all of this wind basically from the southwest right up over, it brings it up right over the southwestern United States. And I would say St. George is probably the northern extremity of where this wind comes to, because it really doesn't end up going up into like northern Utah or really much further north than St. George. Like Salt Lake City doesn't necessarily benefit very much because of these high pressure systems that sit over the southwestern United States. It's really once you get down to really, Cedar City, St. George, that is probably really the northern boundary of where this wind will actually make it up to from the southwest, because Salt Lake City will traditionally get a lot colder and a lot more snow during the winter than southern Utah does. So, but it's all explained once again depending on where these pressure systems are sitting and where the wind's coming from. So you get that southwest wind, well, it's going to be a lot warmer air because it's coming from the equator, and it's going to be dry air as well because it's not traveling over a body of water that has a warm current or has a lot of evaporation going on. So that's, that kind of is the explanation behind the milder St. George winters. When you look at some of the rare days that we have during the winter season for St. George, where you get the random snowstorm, or you get, like a couple of years ago where we got that huge, it was like a week long temperatures, like it was like in the teens all week long. There's usually a couple of days almost every winter season in St. George that are like that. Not necessarily huge snowstorms. Some years are worse than others, but you'll get usually a couple of days where, it gets into the 20s or sometimes even lower. But most of that is just simply random events which causes a shift in these normal prevailing weather patterns, where this high pressure here, we have, if this low pressure that's out over here over the northern Pacific, sometimes it will grow a lot bigger and it'll move down to where it sits over this area of the country, or it's sitting just off of the northwest coast of the United States. Well, when it does that, what happens is it will disrupt these high pressure systems and it'll disrupt the airflow that comes down. So sometimes this low pressure, let me erase my stuff here. Sometimes it will come down and it'll sit right here. Okay. And when it comes down and it sits over that Pacific Northwest area, what happens is it then draws, you can kind of remember this is going to be counterclockwise movement of the air. But if the low pressure comes down and converges in down here, then you can see that the wind that's going to come down and affect the St. George area is going to be coming just like this. It's going to be coming right down from the northwest, where it's a warm current, you have a lot of moisture, and it's going to be really cold. That's your recipe for getting snow in St. George is when you have that, and it doesn't last very long. And like I said, it's more rare, obviously. Generally speaking, in the winter, you don't get snow, and it's usually pretty mild, but occasionally you will get where that low pressure gets big enough over the northwest United States, it moves in and it overtakes essentially the high pressure that sits over the southwestern United States, and your wind shifts and you get that wind coming out of the northwest, and then, like I said, it carries all of your moisture down and brings it into southern Utah. You get the snow. Sometimes it's just rain. If it gets, if it carries enough really cold air, and sometimes you can get multiple things going on here. You kind of see this arrow up here over the polar area. The prevailing wind during the winter is that this polar air likes to travel straight south. And so sometimes what happens is this low pressure will move over the northwest United States, and as this air circulates, so you can kind of imagine it's drawing this air up and around, and what happens is it'll grab this air, but as this air comes south after the polar region, it gets caught up in this low pressure, and then it basically pulls it in to this system, and it pulls it around and down, and it actually becomes part of this air mass that's bringing moisture with it, and then it gets really cold. It'll reduce the temperature, and like I said, it's your recipe for snow, but it's also your recipe for those really, really frigid low temperatures that you occasionally will see in the winter in St. George as well. So, like I said, there's a lot of different, depending on your interest level and things like that, of how much you want to dive into weather, you can really figure out anything that's going on above and beyond, just watching the meteorologists and just taking their word for it and understanding, why they're forecasting things the way they do. It's kind of fun sometimes to dive in and just take a look at the weather charts yourself, and just based on the knowledge that you develop of weather and where it's coming from, and what the moisture situation looks like, what the water temperature situation looks like, you'll be able to quickly figure out and know why it's doing what it's doing, and during different times of the year and anything else. So let's see here. Let's move on. And obviously this same idea exists around the globe, that during the different seasons and different times of the year, you have different, depending on where you live. I use St. George as the example here because that's what most of us can relate to. And I'm not sure, does anybody else have much experience living in other areas that they kind of wonder about, or have ever, like for me now, like living out here in Kentucky, it's been interesting for me to kind of learn about the local weather patterns here where I am, and understanding, why we get the weather we get, why it's humid, why, all of that certain stuff goes on. So, I never paid too much attention to, obviously you pay more attention to where you live, but does anybody have other areas of the country or anywhere that they've lived that they've experienced different weather than just the southwestern United States?
I lived in Georgia for a while, and we had a lot of thunderstorms and things like that around there. It was pretty cool.
Yeah. So Georgia is also, Atlanta is one of those cities that once again, it's kind of rare, but you will get that occasional, you'll get your thunderstorm season, you'll get really humid, in the summer. But then during the winter, you can get that really random ice storm, and it's random enough to say that, no one's ever prepared for it, because it's not normal. It's not normal for them to ever get snow or ice, but when they do, it wreaks total havoc because nobody's ever prepared for it. But you get kind of that combination of the perfect situation where you get like polar air moving down and it converging over the United States during the winter, where it's bringing the temperature down just enough, and you get that warm Gulf air coming up. And if it, depending on where it meets up, whether, depending, we talked a little bit about it, how it meets up in the summer and it causes the tornadoes during the summertime. But when this happens during the wintertime, just depending on where those two systems collide into each other, during the winter is where it's going to, you don't talk about tornadoes obviously during the winter, but we do talk a lot about freezing rain and all of those really bad ice storms. And depending on, if, like in Atlanta, sometimes it makes it as far south as Atlanta, where the polar air coming down will encompass the entire Midwest, and it'll start making its way into the Southeast if it's strong enough. A lot of this, like I said, it depends on how strong the systems are and how much those low and high pressures overtake each other to draw the winds down out of the polar region. But and then obviously, you start taking a look at all of these ingredients, and then this is also what drives your jet stream too. So all those low and high pressures, you get the jet stream coming up all the way into the polar region, and then it brings a lot of that polar air down during the winter. But that polar air, those air masses will sometimes make it all the way down into the southeastern United States over Atlanta, and then that area is where you're also getting that warm Gulf air coming up. And once again, those two slam into each other, and it causes that warm air and that cold air and that moisture, wreaks havoc. That's where you get all your ice storms, your freezing rain, all that stuff. You don't see that stuff out in the West. We don't have any during the wintertime. You don't really have any warm, moist air available to us in the winter. You have it in the summer with the monsoonal effect in the West, in the Southwest specifically, but in the wintertime, the only moist air that you can get for the Western United States would have to come from the Northwest. It would have to come off the coast of Washington up into Alaska, where you have the warm currents. But the problem is because of where it's coming from, by the time it gets to the southwestern United States, you will show up as either just rain or just snow. You'll almost never have an ice situation like you can get in the winter in the Midwest and then the southeastern United States. And that's just simply because the warm, moist air during the winter is coming from the Gulf, where it's more readily available. It's coming from a warm region and traveling north instead of traveling south. So you look at those two combinations, and it can explain everything. And then also the other ingredient to all of that too is the terrain and the mountains that also will disrupt everything in the western United States, where even when you do get moisture coming in, it's slamming into the Sierra Nevadas, it's slamming into all the Rocky Mountain areas, and by the time it even can get to the Southwest, it's so disrupted and so dissipated at that point. Because as weather travels, as it travels over terrain, the weather systems have to completely release all of their moisture in order to get up over the tops of mountains. And so they weaken as it comes down over the Northwest and hits into the Cascades, and then the Sierra Nevadas, and then the Rockies. Anytime it travels over high elevation areas, it's going to weaken those systems. And so you can kind of see why it moderates all of that weather during the winter. Whereas, you get out to the Midwest and the Southeast, there's nothing to disrupt that. There's nothing to weaken those storms. So let's see here. So this thing kind of goes in and talks a little bit more about continental weather. If you're interested in reading a little bit more about it, says the extreme southwestern United States is dominated in the summer by a subtropical high all familiar with the semi-arid summer climate of Southern California. Rainfall is infrequent, but fog is common. And then in the winter, it just basically talks about how it's the opposite. Kind of things we already really touched on. Goes into talking about weather over the open sea, which isn't necessarily something we need to talk about too much in here. But it's depending on, and obviously we're trying to relate everything in here to aviation. So, if you're dispatching, if you have flights, if you end up being in a situation where you're dispatching flights that are international flights, where you're out flying over the oceans, transatlantic, trans-Pacific, flag operation flights, then yeah, you need to know a little bit more about weather patterns over the open sea and things like that. But we don't talk about it too much in here. But it's the same idea. You have a lot of different characteristics everywhere you go. Then it talks about island weather. If you've got flights going into islands, or you're dispatching from, say, the United States to Hawaii, and things that you can expect with island weather as well. But like I said, we don't really spend too much time directly talking about it in here, but it is available in there to read about. Trade wind belts, same thing. Talks about the trade winds, which are kind of more in your tropic regions, and you have prevailing weather patterns, kind of the same theories that we've been talking about, but kind of more talking about the tropic areas and the way that the winds usually blow year round. So let's see here. Let's see if there's anything else that kind of is good for us to talk about. Overall, kind of today's idea here, I mean, the real concept and the real goal for today is for you guys to just understand that every area of the country, every area of the globe is going to have its own unique weather characteristics. And it's not so much that we need to go and talk about every place on the globe or every place that you'll potentially dispatch flights to. It's really just you guys being able to understand the basic theory surrounding anything, really any area, you guys being able to figure out why, if I were to ask, in Maine, in the state of Maine, why is the weather the way it is? Why is it, you should be able to pull out a chart and look at prevailing wind, look at ocean currents, look at the heating elements of the sun, and where it heats things up and which way the prevailing wind is, and you should be able to just take those basic theories and understand why any given area is the way that it is. And it's not that you'll be able to go into detail and explain it necessarily. Over time, you will be able to, because you're going to, as you learn more about specific areas that you dispatch to, and it is all dependent upon where you work and what airports and areas of the country you become familiar with. You're going to learn more about those areas. And so in here, it's not so much about talking about all those areas and understanding each and diving into each of them, but it is understanding the theories that really drive any of it, regardless of where it is or where it's located. I want you guys to be able to have the understanding of what drives the weather, and really for you guys to hopefully be able to get to a point where you can pick out a spot in the United States, wherever you want to look at, and take a look at, okay, well, why is this area of the country the way it is during whatever time of year, and understand it, because that part of it does all come from the same theories, and really just having the basic concept of understanding where's my cold air, where's my warm air, where's my prevailing winds, where's my warm water sources, where's my cold water sources. And once you get a grasp on those things, it'll really help you understand weather pretty much anywhere. And I don't really look, myself, I understand the United States pretty well as far as the weather patterns go, but I don't really get into much outside. I don't really look. I mean, I can understand certain areas of the globe, like when you talk about the Amazon rainforest or the Sahara Desert or the Atacama deserts, any of the like big major areas like that you can understand, but simply due to the fact that I don't have experience sending planes to really pretty much anywhere other than the lower 48 or into Mexico, into Canada, maybe a little bit into Alaska. Those are the areas that I have a pretty good knowledge of. But it's all dependent upon where you work and where you send planes to. That's obviously going to be the areas that you learn the most about. So let's see here. So talking about island weather again. Talks about flying hazards in island weather. Once again, it's not necessarily something we need to spend too much time in here, but you're obviously welcome to read about any of this that you'd like to. Goes into the intertropical convergence zone, which you'll hear about that, but you've probably heard the term before, but as far as from a dispatch point of view, it's not necessarily something you need to know too much about. But just basically talking about, where your tropical weather patterns converge with, the different weather patterns from the northern hemisphere and the southern hemisphere, and what it's really, what it causes, but again, it's really talking about more of your tropics area. So let's continue on here. Starts talking about those monsoons, talks about Asia, and I'm sure everybody in here has probably heard about the monsoonal season, especially over in Asia, Southeast Asia. They get those monsoonal times of the year where they just get absolutely drenched in rain for a couple of months. And once again, it's all the same idea. It's the same. It's just simply looking at the weather patterns and what it's doing at that time of the year, and the wind shift that time of the year, the water source. It's the same principles, it's the same theories, but just looking at a different area of the globe and where it's located in conjunction with all of those patterns. And it will explain itself away just by looking at that. Let's see here. You can read a little bit about this as far as Asia goes. So the summer wet monsoon weather. During the summer, the low over Central Asia draws the warm, moist, unstable air from the southwest over the continent. Strong surface heating, coupled with rising air flowing up higher terrain, produces extensive cloudiness, copious rain, numerous thunderstorms. Rainfall at some stations in India exceeds 400 inches per year. So the monsoon is so pronounced that it influences circulation many miles out over the ocean. Let's see. Goes into a little bit about the weather in Africa, South America, the Amazon Valley. Okay. This here is talking about big air masses converging into each other, and it can create what's called a shear line and an induced trough. So what happens, we were kind of looking at some of those air masses before, like where you get the high pressures overtaking low pressures, but you also have different scenarios where if you have a couple of different high systems that are near each other without having a low pressure system anywhere in there in the mix. Sometimes you have several high pressure systems that all converge in on each other. And this is kind of what this is showing here. But if you have a high pressure system that's over a polar region and it comes into contact with another high pressure system that's over a tropical area, you're going to have two, although they're both high pressure systems, they're carrying two different types of air, one being cold polar air, the other being warm subtropical air. And what happens is when if those two pressure systems bump up against each other, then it creates what's called a shear line. And those shear lines, so it's one of the things that'll help drive the jet streams, because like when you look at the jet stream, and if you've ever wondered why the jet stream shifts around so much, well, it's really at the end of the day, there's not necessarily there's not like there's a huge, I mean, when you look at the jet stream on a map, you see like this huge wavy line with an arrow on it, and everyone's kind of gotten used to seeing that on the news and stuff, and the weatherman showing you. But there's really no such thing as, like this huge channel of air. It is like a highway of air, but the thing that's creating that jet stream is all of these air masses and their boundaries. So if you have a high pressure system like this chart is depicting here, if you have a high subtropical air system that has warm air in it, and it's bumping up against a big high pressure system that has cold polar air in it, it is going to create a boundary line, which is what this is showing you, a cold front, a shear line. But that's what that's going to do, is it's going to drive that highway of air in a way. Like when you think of the jet stream, it looks like this big highway in the sky traveling over wherever it wants, going north, going south. But, from east to west it still curves up and around, but it still generally goes from the west to the east. And the reason it moves around so much, though, is because it's following these boundary lines. It's going up around this high system and then hitting into this other cold air system, and then it goes south, and then it gets drawn back up to the north. And the reason you get that big waviness of the jet stream is just because there's all of these pressure systems out there that have cold air, warm air, and you get all these boundaries in between them. And that's where it forces the air to travel, is in between all of these systems and along these boundary lines. And it's also, what causes, these cold fronts and warm fronts. When you get high pressure systems up against each other, you normally get, what happens is they normally stay there, and you get these, the weather in that area becomes very stable, but it's not like the actual air itself isn't necessarily moving around a lot, because high pressure systems, what they generally like to do is it's very stable air, first of all, in a high pressure system. So stable air doesn't really move very much. That's why we associate it more with good weather. But when you have a high pressure system that kind of comes into an area and it just will sit there on top of a geographic region, and if it has cold air in it, then it's going to make it stay cold in that region for a week or 2 weeks or sometimes 3 weeks, until you can get something else in there, some sort of system coming in to move it out of there. It takes a lot, either a really big low pressure system to come in and kick out a high pressure, or a different high pressure with different types of air to finally come in and overtake like a really high pressure cold air system. So one example of this, like if those of you that are familiar with Salt Lake City, in the wintertime, you will get really bad inversion up in Salt Lake City. Does everyone know what inversion is? And I'm not sure how many of you have dealt with inversion in the winter, Salt Lake area, or have seen it. I'm sure you've heard about it. But what happens in that scenario is the recipe for an inversion is, first of all, you have to have a mountainous region typically to have inversion. And what happens is those mountains, you get a big high pressure system, and in the winter especially, a high pressure system, like I was saying earlier, it'll come into a geographic region and it'll just sit there. It'll sit there for 2 or 3 weeks at a time before it moves, and that it's a very stable system. The air doesn't move around, and what happens is when a high pressure in the winter, when it moves over, say, the Salt Lake City area, is the high pressure system, all of the pressure is coming. If you look at the characteristics of a high pressure system, the pressure is actually coming from above, and it's pushing down on top of whatever air is already in the area. So a high pressure system overtakes an area by going over the top of it, if that makes sense. And a low pressure system is exactly the opposite. The pressure from a low, the wind is actually, or I shouldn't say the wind, but it's bringing wind up from the bottom and sucking it up into the atmosphere going out the top. High pressure brings air from the top and sucks it down and pushes it down on top of the air that is below it. So they're exactly the opposite in their characteristics. One is counterclockwise, one is clockwise. But a high pressure system brings the air in over the top and pushes it down through the middle of the high pressure down on top of a region. So when you get Salt Lake City as an example, and you get that inversion, it comes in over the top of Salt Lake City, and if you have cold air or whatever air exists in Salt Lake at the time will end up getting trapped underneath a high pressure system. And as the high pressure just comes in, and it'll just camp out for 2 or 3 weeks at a time. And that high pressure system will not move until another system of equal or greater power comes in to push it out. That's the only time, the high pressure will leave. But because it's rare, the high pressure will end up staying there, 3 weeks, 4 weeks, even sometimes at a time. And as it sits there over the space of 2 to 4 weeks, the air underneath it, because there's so much pressure on it, cannot escape. And mostly that's because of the terrain, the mountains that are in the area. It doesn't allow the air to escape the valley. And you get that really, really bad valley inversion. You get all of the smog and all of the particles in the air from traffic, and any sort of pollutant in the area will get trapped underneath the high pressure system, because once again, that pressure is coming from the top pushing down, and it compacts all of the air underneath the high pressure system, and it doesn't allow it to escape. It doesn't allow it to go up because there's pressure coming down on top of it, and it doesn't allow it to go out the sides because there's terrain blocking it in. So you get all of that stuff gets trapped in valleys, and the longer a high pressure sits there, the worse an inversion will come or become over the space of several weeks as it sits there on top of it. And then you also have the actual inversion itself. What it really means, when they give it, or when they coin it as an inversion, when they coin that term, it's really meaning that the temperature above is warmer than the temperature below. So if you've noticed, if you've ever been in an inversion environment, you'll notice that all the air gets trapped there, and it's also extremely cold. Extremely cold air. When you go above the inversion, if you can get up high enough and get out above it, you'll notice that the temperature is a lot warmer than all of the air stuck down in the valley. If you've been in that situation, like in the Salt Lake City situation, a lot of people, if they want to escape the inversion, they'll drive like up, and they'll go up into like Park City or go somewhere up into like the ski resort areas, and it'll get them out of the inversion, and the temperature will also be a lot warmer, and it'll be clear. There won't be any fog or any pollution, and they kind of use that to get an escape from the inversion during those really bad high pressure, where you'll get that high pressure sitting over the valley for weeks at a time. That's all people can do to get out of it and escape it. So those of you that are familiar with that phenomenon, during the winter in Salt Lake, hopefully that kind of helps explain it a little bit, but it kind of is explained a little bit with these boundary lines and other things. So, but anyway, yeah, I know our time is pretty much up for today. So anybody have any last minute questions before I turn you guys loose for the night? The idea obviously today was really just to kind of get a basic understanding of weather. We're going to obviously continue to talk about it, over the next several days. But if you want to, understand any of this theory a little bit more, feel free, read through this. It's only going to help. If you have time, bring up this document. It is under today's folder, so you can get in here and read up on any of this stuff that you want to learn more about. The more you know, the better, obviously. So, yeah, unless you guys have any questions or want to talk about anything else, I will let you guys go for the night and talk to you guys again soon.
Thanks, Adam. Good night.
Thanks.
Good night.